Okay, let's unpack this. Welcome to the deep dive.
Glad to be here.
You've shared some really interesting sources today. Looks like a research report.
That's right. It digs into the foundations, the tech, and, the actual uses of AI in space exploration.
Right. So our mission basically is to walk you through this material. We want to pull out the key bits of knowledge about how AI is, well, really changing our reach into space.
And what it means for you listening in.
Exactly. Because AI isn't just like a concept for the future in space.
Not at all. The sources make it clear it's already tackling massive practical challenges, things humans just can't do on their own.
Like what specifically?
Well, think about the huge communication delays, sending signals over millions of miles.
Yeah, that lag time is killer.
Right. And then there's just the sheer volume of data coming back from, say, a Mars rover or a space telescope. It's overwhelming.
Uh-huh.
AI is actually making it possible to handle that, to make sense of it all. It's genuinely expanding the frontier.
It's pretty amazing. And the report goes way back, right? It connects modern AI to ancient philosophy. That seems unexpected.
It does, yeah. It draws parallels like between Plato's ideas of innate knowledge, sort of top-down thinking,
Okay.
and how early symbolic AI worked. Systems based on pre-programmed rules, logic puzzles, proving theorems.
Got it. Rules first.
Exactly. And then you have Aristotle, focused more on learning from observation from the world around us, empiricism,
Right. Learning from experience.
which is the core idea behind bottom-up AI, machine learning, neural network systems that learn patterns from vast amounts of data.
So data first. It's fascinating that those old debates still echo in like how we build AI today.
It really is. Shows these are fundamental questions about knowing and learning.
So how does this translate? How does AI actually, see or understand things happening so far away?
Okay, so that gets us into core technologies. Computer vision is a big one. That's AI seeing.
Analyzing images, video.
Precisely. Essential for a rover navigating tricky terrain on Mars, or maybe spotting something interesting geologically, or even inspecting the outside of the space station.
And language. NLP.
Natural language processing.
Yeah.
That lets AI understand human language. Think mission logs, scientific reports, astronaut instructions.
Right. Making interaction more natural.
Exactly. And the sources really stress the importance of these foundational models now.
The big pre-trained ones. What's the deal with those?
Yeah. Think of them like super smart starting points, trained on massive data sets, then fine-tuned for specific jobs.
Okay.
The report mentions Space Llama, a version of a large language model used on the ISS.
Helping astronauts directly.
Right. Accessing technical manuals, procedures instantly, without waiting for a signal from Earth. That bypasses the whole communication lag problem for certain tasks.
Wow, that's a practical benefit.
Huge. Another example is Prithvi WXC. That's a collaboration, IBM and NASA. It's trained on Earth observation data.
So for weather and climate.
Yeah, powerful analysis capabilities, even usable from orbit looking down.
So AI is really becoming an active partner then, not just a data cruncher.
Absolutely. It's boosting what humans can do.
Yeah.
Take the Perseverance rover on Mars.
Right. It drives itself quite a bit.
A lot, yeah. Using AI to see the path ahead, identify obstacles, plot its course autonomously.
Without waiting for commands from Earth every few minutes.
Exactly. And there's stuff like the AI4LS initiative that's artificial intelligence for life in space.
What's that about? Astronaut health.
Primarily, using AI to model and predict health risks. They're looking into things like digital twins.
Like a virtual copy of the astronaut?
Sort of, yeah. A model of their biological systems to simulate risks. And also federated learning.
How does that work?
It lets AI learn from sensitive health data without that data having to be sent anywhere. It stays secure, protecting privacy.
That's crucial for long-duration missions.
Definitely. Proactive health management while keeping data private, deep in space.
Incredible stuff. But, okay, more autonomy means more complexity, more challenges, right? The sources touch on ethics.
They do. It's a major consideration. Who's responsible if an autonomous system makes a critical error millions of miles away? How much oversight do we maintain?
Big questions.
Huge. And beyond ethics, there are technical hurdles. Ensuring the AI is robust, reliable in that harsh space environment, power constraints, computational limits.
And just testing these complex systems before they launch must be hard.
Extremely. Rigorous validation is key, defining how humans and AI work together, especially when the stakes are so high.
But it's not all challenges. The report also highlights opportunities, right? For you listening.
Yeah, definitely. There's a ton of public data out there.
Yeah.
NASA's Open Data Portal, for instance.
So you can actually get data sets from Mars missions. things like that.
Absolutely. Earth observations, planetary data, it's accessible.
And resources to learn how to use it.
NASA even offers courses like one on AI and machine learning in space biology, openly available.
So the chance is there to not just watch, but maybe even experiment with real space data yourself.
Exactly. Using public models, maybe training your own, contributing to understanding some of these big questions.
Okay, so this deep dive, it's really been a shortcut, hasn't it? Getting up to speed on AI's role in space.
Yeah, from those surprising philosophical roots.
With the core tech, like CV and NLP, the foundational models.
The practical uses like rovers and astronaut health.
And facing those tough ethical and technical challenges.
We've really seen it's not sci-fi anymore. AI is an essential tool today. It's augmenting us, pushing boundaries.
So as we wrap up, here's something for you to think about. As these AI systems out there in space get more and more autonomous, handling critical tasks far from our immediate control, what new responsibilities do we take on back here on Earth? And how might this shift, this increase in machine autonomy, actually change the whole nature of exploring the cosmos?